Hello, pre-calc. There was one little topic I didn't quite get to in class. I just want to make sure you have a little bit of help on the homework. So let's go over it. It's about absolute value inequalities. We did a lot with inequalities in class, but and in class what we did was we solved some inequalities with a sign chart and a number line. But there was one page with a couple examples of what an absolute value equation or an absolute value inequality is. So an absolute value equation, let's look at that first. So this is not an inequality. We're looking at something like this. What if I have the absolute value of x equals 2? Well, what makes that true? Well, x equals 2 or negative 2 make that true. Because if I put absolute value of 2, that equals 2, that's true. Absolute value of negative 2 equals 2, that's true as well. What about x minus 2 absolute value equals 3? Okay, well, I need the difference between x and 2 to equal 3 or negative 3. So one way to think of this is, an algebraic way of thinking of this is either x minus 2 equals 3 or x minus 2 equals negative 3. So this would be what? X equals 5 or x equals negative 1. Now, let's graph it, because graphing it can give us another insight. Let's graph this situation. So I'm going to draw a number line, and I'm going to put 2 here, and then notice 5 is 3 units to the right of 2, and negative 1 is 3 units to the left of 2. 1, 2, 3, that's 5. 1, 2, 3, that's negative 1. And the two solutions over here to this equation are here and here. Notice this. The 2 is the center, and 3 is the distance from the center. The center is 2, and the distance from the center takes you to the 2 points that make the equation true. Now, just in this little area here, I'm going to put one more example. What if I had x absolute value is less than 3? Well, we can think of that as absolute value of x minus 0 is less than 3, and the center is 0. So I'll put 0. Now, if this were equal, which it's not, but if it were equal, we could go 3 units to the right and 3 units to the left, and our solutions would be here and here. But we want the absolute value of x to be less than 3. So we want the distance from x to 0 to be less than 3. And if you think about that, what it means is any number that's between negative 3 and 3 will make that true. Because if I plug in 1, well, the absolute value of 1 is less than 3. If I plug in 2, the absolute value of 2 is less than 3. If I plug in 2.99, the absolute value of 2.99 is less than 3. And if I plug in the negative corresponding numbers, like negative 2, if I put negative 2 here, absolute value of negative 2 is 2, and 2 is less than 3, so that's true. And if you plug in any number between negative 3 and 3, it satisfies this inequality. The advantage to writing it this way, the way I did, was that we can see where the center of the graph is. The center is here at 0. And what's on the other side of the inequality is the distance you go from the center to get to the boundary. So what we end up, if we follow the pattern that we start to see as we graph these, our our expression must lie between two boundaries or beyond two boundaries. I'll show you the examples. We just graphed above the first two where all of the values of x that make it true lie between the boundaries. So if I have absolute value of x is less than c, then any number between negative c and c will make this true. If I have absolute value is less than or equal to c, the only difference is we include the endpoints because the endpoints make it true. If I have absolute value of x is greater than c, then that means the distance x is from 0 is more than c. So if x is over here, the distance x is from 0 is more than the distance c is from 0. And the or equal to just includes the point. So if we were to summarize this, what we have is this. If I have something like x minus a is less than b, a is the center, b is the distance you go from the center to the boundary. We call that the radius. And I have that down here with this example. So let's graph this example. X minus 5, absolute value, is less than 2. Well, the center is 5. I've already put 5 on the number line here. And the distance I go to the right of 5 is 2 units, and the distance I go to the left is 2 units. And so that would be here. That's 7 and 3. Now this is less than, so we're not going to include the boundary. But any number between 3 and 5, any number between 3 and 7 will make this absolute value inequality true. By the way, just so we have a nice drawing, if I were to do absolute value of x minus 5 is greater than 2, so I only changed the inequality, I didn't change the numbers, that graph would look like this. 5, and we go 2 units to the right and 2 units to the left to 3 and 7. But instead of including all the numbers between 3 and 7, any number outside of 7 or any number outside of 3, to the left of 3, less than 3, will make this true. So when the inequality is absolute value less than a number, you shade inside the boundaries. And if its absolute value is greater than 2, we shade outside the boundaries. So a couple quick examples. What about number 98 here? What's the center? It's 0. What's the radius or the distance to the edge? It's 4. So the equation of this given graph would be x minus the center and is less than, because it's on the inside, it's less than 4 units. There's 4 units, 1, 2, 3, 4. There's 4 units to get to the boundary. Now I did less than because it did not include the endpoints. This one here, the center is 1, so x minus 1, absolute value, is less than or equal to 4. The center is 1, is less than or equal to 3. The center is at 1 here, and the radius, the distance from the center to the boundary, is 3 units. So that's why this is a 3. Now on this one, we have everything, the center is at -2, and everything outside of the boundary is shaded. So this one would be absolute value of x minus -2, and we would have greater than the distance from the center to the boundary, and that's 1 in this case. So that would be 1. Absolute value of x plus 2 is greater than 1. Last one. This is the general form, just to recap from above. it's always x minus a is greater than or equal to b, or less than b, or less than or equal to. You can flip the inequality sign around depending on what you want. Remember, when you have the minus, x minus something, then a is the center. Well, what's the center in this one? Well, we have to rewrite it with a minus. It's x minus -1 absolute value, and that's greater than or equal to 1. So this is going to be shaded on the outside. The center is at -1, so the center is here, and we go 1 unit to the right and 1 unit to the left. I'll graph this in red. We include the boundary, so the center is at 1. Center. We go 1 unit to the right and left of the center, and then anything that is outside of that boundary makes the inequality true. Okay, I think that should be enough to do the 4 or 5 problems that are on your homework, and I will see you next time. Bye.